Hello children, today I am going to teach you the electrical lines of force. What is electrical lines of force? Suppose a charge body, Q, so electric field is extended, electric field, electric field is there, it is extended up to infinity. Now, electric lines of force is the imaginary line drawn by unit north pole. Imaginary line by unit positive charge in electric field. Electric field. 1. Now there are some properties of electrical lines of force. Properties 1. These lines of force originate from positive charge and terminates at negative. That means like this, positive to negative, like this. It is not closed. Lines of force not closed. Clear? Properties number 3. They produce lateral pressure. They lengthwise they contract. Okay, imaginary line by unit positive charge in electric field. These lines of force originate from positive charge, terminates as negative, like this. They produce lateral pressure like this. It is lines of force, another lines of force. So lateral pressure is produced like this. Now, next property is number 5. Tangent at any point drawn will give us direction of E, electric field. Clear? Next body is tangent drawn. So if this is the lines of force, any tangent at the point P will give the direction of tangent, and this will give the direction of field. Tangent drawn at the point P, this is the lines of force, will give the direction of field. Now, two tangent, so we can write easily that two tangent cannot cross if cross like this. We can draw two tangents are there at the point P. There is a two tangent, one is this and another is this. So at the same point we get two tangents, two tangents. That means two direction. Now same point we get two tangents, two directions. So E cross we get two tangents. Now for another properties, for uniform field, lines of force are like this. Lines of force parallel and equal spaced. Uniform field. It is uniform field. Uniform field. Lines of force parallel and equally like this. Now at Dean's lines of force means E is very strong. E is very strong. These are the properties we discussed. Now tangent at any point drawn will give the direction of electric field. Two tangents cannot cross. For uniform field these are parallel. At dense lines of force means where the lines of force are very close, the electric field is very strong. Now children, these are the basic properties of lines of force, and last properties that I am going to discuss with you. Lines of force perpendicular to equipotential surface like conductor. Equipotential surface like conductor. Now this is the conductor. Conductor lines of force will be perpendicular. The angle is 90 degree. It is the DI, angle is 90 degrees. So lines of force perpendicular to equipotential surface like conductor. Okay. Next I am going to discuss with you, that is relationship between this is relationship between potential and electric field. Relationship between potential and electric field. That means two basic properties. One is electric field, electric intensity. Other is electric potential. Potential and field. Potential is a scalar quantity. So electric field is always defined by two physical quantities. One is the scalar, other is a vector. There is a close relationship in between electric field and what is the field? Suppose Suppose Q is the charge at the point A in an electric field is along the direction AB. Q0 is the charge along the direction of electric field. Now you displace charge Q0 against the field. Against the field. So against the field. Now work done dW equal to force and displacement. Now displacement is dr, b to d dr. So work done dW equal to minus q0e, that is the force, into dr. Equation number 1. Because in this direction electric field, or you are displacing the charge against the field, so negative work is done. So Q0A is the force and dr is the displacement. So this is the work done. Again you can write work done dW equal to Vd minus Vb into Q0. This small gap of potential difference you can write dV Q0. That means B and D are very close. So Vd minus Vb equal to dV, small potential difference, into Q0. So we can write from 1 and 2. Now from 1 and 2 we have Q0 E dr equal to dV into Q0. That means equal to minus dV by dr. You remember, equal to dV by dr, that means electric field is a conservative force field. So every conservative force field, E is conservative, E is a conservative force field. So you can represent any force field in terms of gradient of a potential or conservative force field. You know in mechanics that where the work done does not depend on the path. It does not depend on the path. So it is a conservative force field. So potential related to field, like gravitational force, also conservative force field. There is a gravitational potential also. In class 11 I think you have learned, children. So again I am telling you, Q is the charge which is producing electric field along the direction AB. Now you are putting a charge at the point B, Q0, and displacing the charge against the field by dr. So according to definition of work, force into displacement, already in mechanics work energy power you have learned, force equal to minus Q0E into dr. This is the dW, that is the work done by electrical force. Now again we can write the same work done with the help of potential difference. Now B and D are very close. If B and D are very close, means you are getting this work done dV into Q0. So we have Q0 E into dr equal to dV into Q0 E equal to minus dV by dr. That is equal to, if you know the V, then you can take the derivative with first order derivative with respect to position coordinate. You are getting electric field. So once you know the V, you are getting electric field. That is very important formula with associated with this chapter. Next theory, what I am going to discuss. Now, if two charges, suppose at A Q is charge, at B there is a Q0 charge, gap between them are between the them. Then due to interaction by the field we have potential energy equal to U, that is equal to Q0 4 pi epsilon naught by into R. If there are so many charges, so we can write easily total potential. If there is a 3 charges, suppose Q1, Q2, Q3, so we have potential total equal to 1 by 4 pi epsilon naught. You are getting Q1, Q2, R12. R12 is the distance between them, in between the R12, and it is R13, and it is R23. You are getting Q1 and Q3 R13 plus Q2, Q3 by R23. অর্থাৎ you are getting potential energy in terms of charge by pairing Q1, Q2, Q1, Q3, Q2, Q3. Next, I have to derive how potential energy formula. Suppose Q is the charge at the point A, at a distance R, there is another charge small q. Coulomb force F equal to 1 by 4 pi epsilon naught product of the charges by R square. This is the Coulomb force. Now this charge is shifted to down. This is the Coulomb force. Now displacement dr against the force. So we have dw equal to minus. Why minus? You are bringing the charge very close to q, so you are getting 1 by 4 pi epsilon naught q by r square into dr. Now total work done W when you are taking suppose RA, RB 1 4 by epsilon naught R q small q by r square into dr. After integrating, you are getting 1 q small q by 4 pi epsilon naught outside, and by integration you are getting r to the power minus 2 plus 1 minus 2 plus 1 RA to RB. So you are getting work done, that is equal to Q small q 4 pi epsilon naught. You are getting 1 by RB minus 1 by RA. Upper limit minus lower limit. Minus minus a plus. This minus and this minus will get plus. So you are getting 1 by minus. So we have now this is the, what is this? This is the final potential energy minus initial potential energy. If now go to the top again, we can write we are getting work done equal to W equal to work done equal to Q by 4 pi epsilon naught 1 by RB minus 1 by RA, that is equal to final potential energy minus initial potential energy. Question is, if RA equal to infinity, then UI equal to 0. You know, potential interaction when the charge Q is at infinity, we are getting potential, final potential is 0. So we have क्या होगा, W equal to Q by 4 pi epsilon naught 1 by RB. Now work done by charge equal to potential V equal to Q by 4 pi epsilon naught by RB. This is the formula for potential at the point B. Thank you all.